Dear students, let us continue our learning on the course Data Structures and Applications. This video is the first session of the fourth module. The topics which are covered under this session are basics of trees and the terminology used in the trees. Myself, Dr. Suresha D from the Department of Computer Science and Engineering of Canara Engineering College, Bantuwal, Mangaluru. So if we go with the trees, so in the beginning sessions, we classified the data structures in under two main headings, if you remember, that is primitive and the non-primitive data structures. In the primitive data structures, we learned the basic data types like integer, character, float, double, and all. In the non-primitive data structures, we again classified them into linear and the non-linear data structures. The trees are a part of non-linear, non-primitive data structures. If we go with the definition of the tree, a tree is a finite set. A tree is a finite set of one or more nodes such that there is a specially designed node called a root node is present. The remaining nodes are partitioned into in disjoint sets. So it may be 1, it may be 2, or it can be more. They are numbered as a T1, T2, T3 up to Tn, wherein each of these sets is a tree itself again. And the trees that is a T1 to Tn are called as the subtrees of the root. Let us take this one. Fine. First is a tree is a finite set. So it will have the finite number of nodes in it. So set is nothing but the elements which are present in the trees, they will be termed as the nodes. They are the nodes of the tree. Fine. The first node we call it as the root node. So whenever we go at the trees, the root node is the one for which no incoming edges are present. So if we take this example here, the first node A, right? So that node will be called as the root node because there is no incoming edges to it, and all the edges means the branches, if you can see. There are three branches are there. One is leading to B, other is leading to C, and the next one is leading to D. Right? So now there is no edge which is coming towards A. All are going out of the A to B, A to C, and the A to D. So that is the node, the root is a node which has no incoming edge to it. So it is the first node. It's what we call the root node, the base node, from where our tree is originating. Over. Right? So next, if you take up that A, so A has three children over here. You can see B, C, and the D. So these B, C, and the D, so they themselves are one small trees. They themselves are one small trees. So that is, you can see the things clearly over here. That is, B again is a tree which is having the elements B, E, F, K, and the L. C is again one more tree which is having the elements C and the G. And the D, H, I, J, and the M, they are one more tree. Right? So they will be called as the subtrees. If I go with the B, so B again is having the two child. One is the E, other is the F. So they themselves are again one tree. So they will be called as the subtrees. That is, if you go more formally, so what happens? There is an specially designated node called the root node. So root is the first node, as I told. In the A tree, if I take up, A is the root node and the rest will be your subtrees. If I take up the B part, B is the root node, so and Rest of the things will be the subtrees. C is a root node and G is a subtree. So like that, the tree is made up of small subtrees, and if we take up these small subtrees, they will be the again they will have one root over there. Right? So that this representation, this overall representations, we call it as a tree. So tree start if we go with our binary number system. Let us take that as well. So what happens first? Let me take the example. So 10. So from here we will start up. Then next 5. Then next, let me take it as 15. So now if you take up the tree notation, now 10 is a root node. 10 is the root node. So it is having, so 10, the whole together is one tree. This whole together is a one tree, and it is having the two subtrees. So this is my first subtree, this is my second subtree. It is having the two subtrees over there. Right? So this is how the trees are represented and they are used. Right? So now let us continue. Next, so each entity in a tree, so if you go with the tree, there are two components. One will be these A, B, C, D, E, F, G, H, I, J, K, L, M. So they are termed as the nodes. They are termed as the nodes. And the edges which are connecting the nodes. The edges which are connecting the nodes, so they will be the branches. They will be the branches. Fine. So they flow from top to bottom, even though there is no direction is there. They flow from top to bottom. That is from A to B, A to C, A to D, then B to E, B to F, then E to K, E to L, then C to G, then D to H, D to I, D to J, and H to M. Fine. These are the branches. Fine. Then next, if you go with the node actually will have our information. The content of any node is will have the information in it. So along with the information, it will have the link to the other nodes. Along with the information, it will have the link to the other nodes. So if we take the same tree again, so now this is having the first will be my information is A, and it is having the three links over there. One link is towards B, then next link is towards C, then next link is towards D. So this is nothing but your branches. So this is your information along with the branches, means links to the other nodes. Right? Then if you go with the degree of a tree, the number of subtrees of a tree will be the degree, number of subtrees. So if I take up A as an example, how many subtrees I have? 1, 2, and 3. Fine. So next, if I take up the B, how many children it have? 1, 2. If I take up the C, 1. If I take up the D, it is 1, 2, 3. Fine. Then if I take up the K, it has don't has any child. This one, no. This one, no. So now if I write formally, so A is having 3 children, correct? Then if I go with the B, B is having 2 children. If I go with the E, E is having 2 children. If I go with the F, F is having 0 children. If I go with the C, C is having 1 children. If I go with the G, G is having 0 children. If I go with the D, D is having 3 children. H is having 1 children. I is having 0 children. And J is having 0 children. Fine. So now if we go with the degree of the tree, so that is nothing but the number of subtrees. That is degree of A is 3. Degree of B is 2. Degree of C is 1. Degree of D is 3. Degree of E is 2. Degree of F is 0. Degree of G is 0. degree of h is 1, degree of I is 0, degree of j is 0, degree of k is 0, degree of L is 0, degree of M is 0. Fine. So now, what is the degree of this tree? So now what we learned is the degree of each node. Degree of each node. What is the degree of each node? The number of subtrees of a node, we call them as the degree. We call them as the degree of the node. So if we go for the degree of a tree, the maximum of the degree of the nodes is the tree. So now what is the maximum degree over here? So we have the value 0, we have the value 1, we have the value 2, and we have the value 3. Correct? So now what is the maximum value? 3. 3 is present in two places. That is the degree of A is 3 and degree of D is also 3. So you can take any value. So the degree of this entire tree is 3. That is the maximum of the degree of the nodes in a tree. We call it as the degree of a tree. Fine. Then next, the terminal nodes. Then the terminal nodes. So let me rub the entire thing again first. Let me clear this one. Okay. So now when we go for this representation, so let me write the degrees again. So degree of A is 3, degree of B is 2, degree of E is 2, degree of K is 0, degree of L is 0, degree of E is 0, degree of C is 1, degree of G is 0, degree of D is 3, degree of H is 0, degree of I is 0, degree of degree of H is degree of H is 1. Degree of H is 1 because M is present over here, right? Degree of J is 0 and degree of M is 0. Fine. So now, if we take this one, now to call them as the terminal nodes or the leaf nodes, to call any node as a terminal node or a leaf node means the nodes whose degree is 0. The nodes whose degree is 0. So if we take up what are all the nodes? First K. K is a node whose degree is 0. L. L is a node whose degree is 0. Then F. F is a node whose degree is 0. Then G. G is a node whose degree is 0. Then M. M is a node whose degree is 0. Then I is a node whose degree is 0. Then J is a node whose degree is 0. These nodes whose degree is 0. So in other words, we call it as the nodes which don't have the successor. Means the underneath those nodes we don't have any other nodes. Down the K we don't have any other node. Down the L we don't have any other node. Down the F we don't have any other node. Down the G we don't have anything. Down the M we don't have anything. Down I no. Down J no. So such nodes we call them as the terminal nodes or the leaf nodes. So if we go with the definition of this one, these are the nodes that have degree 0 or node with no successor. So such nodes we call them as the terminal nodes. Then the non-terminal nodes. Leaving the terminal nodes, all the rest of the nodes whose degree may be 1, 2, 3 or it can be any value. Such nodes we call them as the non-terminal nodes. So terminal nodes are the nodes whose degree is 0 or the node with no successor. We call them as the terminal nodes. Non-terminal nodes are the nodes that won't belong to this category, means terminal category. The rest of the nodes whose degree is non-zero, we call such nodes as the non-terminal nodes. To continue, next, parent and the children. Fine. So now let me take one simple example. So let me have the example. Let me take the example of our Amitabh Bachchan. Fine. So Amitabh Bachchan. So let me take it as a node. So now E is having the two children. One is Abhishek Bachchan. One is Abhishek Bachchan. Other is having a daughter. Her name I won't remember, so I am writing it as a daughter. So now in this case, fine. So in this case, this relation we call it as the parent-children relation. Parent-children relation. That is a root and the subtree you can see. Amitabh is the root, correct? Abhishek and the is a sister. They are the subtrees of the Amitabh. Fine. That is, if we go in general, A is a node whose children are B, C, and the D. So now B is a parent of E and the F. E is the parent of K and the L. K and the L are the children of E. E and F, they are the children of B. Fine. B, C, D, they are the children of A. Fine. So that relation we call it as a parent-children relation. Fine. If we go with the definition wise, suppose N is a node in a tree with the left successor as S1 and right successor as S2. Then N is said to be the parent of S1 and S2, wherein S1 is the left child and S2 is the right child of the N. Fine. So similar to that of your Amitabh Bachchan case, what we told. Fine. Abhishek and his sister, they are the children of Amitabh. In other way, Amitabh is the parent of Abhishek and the daughter. Fine. Next, if I take up Amitabh and his sister, they will be termed as the siblings. They will be termed as the siblings over here. Fine. So now, if we take up the example here, so here, the children of the same parent. The children of the same parent, we call them as the siblings. Children of the same parent, we call them as the siblings over there. Right? If I take up Sunny Dial, Bobby Dial, and the Dharmendra example. So that is Dharmendra will be the parent. Dharmendra will be the parent, and Sunny Dial and Bobby Dial, they are the brothers. Correct? So Dharmendra will be a node. So then he is having the two children. One will be Sunny Dial, other is the Bobby Dial. Fine. So now Sunny Dial and Bobby Dial, they are the children of Dharmendra. Fine. And Dharmendra is the parent of the Sunny Dial and the Bobby Dial. Fine. And if I take up Sunny Dial and the Bobby Dial, they will be termed as the siblings. That is, the siblings are the nodes of the same parent. That is, the children of the same parent, we call them as the siblings. Children of the same parent will be the siblings. Right? Then edge. A line which is drawn from N to T, fine, where N to T, that is a successor. So that is a no in this case. So now this is N and this will be T. So now we draw one line over here, right? That is a line drawn from node N of a tree to the its successor. Fine. So that is a T is the successor of N. Sunny Dial is the successor of Dharmendra. Bobby Dial is the successor of Dharmendra. That is a edge which was drawn from Dharmendra to Sunny Dial, or a edge drawn from Dharmendra to Bobby Dial. We call it as a edge. The line which was drawn, we call it as a edge. Fine. Then a path. If you go with the path over here, that is a sequence of consecutive edges. That is, if I take up this example, now if I take up the K. So how I can go to K? From A to B, B to E, and E to K. Fine. So this root of edges, this root of consecutive edges, To reach that node, we call it as a path. We call it as a path in the terminologies of the trees. Right? The next, ancestors. Right? So now ancestors means, suppose if I take up the K. For the K, you, fine. For the K, E is the parent. Correct? The next, B is the grandparent. Then A, greater grandparent, right? Greater grandparent. Right? For K, the ancestors are E, B, and the A. Sibling L. For the K, sibling is L. The parents are E, B, and the A. Fine. That is all the nodes along the path from the root to that node. We call it as the ancestors. We call it as the ancestors over there. Fine. Then the level of a node. Fine. So if I go with the level, first A is at the level 1, 2, 3, and the 4. So the levels we can compare with your generations. The generation of computers. Fine. So that is nothing but the computers which are there under that level. Fine. So level of a node is defined by letting the root be at the level 0. If a node is at level 1, then its children is at the level L plus 1. Fine. So it will start by the level value of 0. That is, if I take up this one A, so A is a root node whose level we start with 0. The next one we start with the 1. Next one we start with the 2. Next will be our 3. So if we go for generalizing this one, if I am there at my level L, means my children will be there at the level L plus 1. My children will be there at the level L plus 1. Fine. Then the height or depth is the maximum level of any node. The maximum level of any node will be the height or the depth. Height or the depth will be the maximum level at of any node. We call it as the height or the depth. Let us take the example over here. Right? So in the textbook, it is a textbook example wherein they are starting with the level of 1 over here. A is at the level 1, B, C, and the D, they are there at the level 2. E, F, G, H, I, and the J, they are at the level 3. K, L, and the M, they are at the level 4. Right? So let us continue this example. Here, A is the root node. Why it is called as the root node? Because there is no edge which are coming towards it. So all the edges are going from it. That is, the edges which are going out of it are, one will be to the B, other will be to the C, other will be to the D. So A is the root node of this example. Then A is the parent of B, C, and the D. Correct? A is the parent of B, C, and the D. B, C, and the D, they are the children of A. B, C, and the D, they are the children of A. If you take up the first subtree, B is the parent of E and the F. E and F are the children of B. In the same way, K and L, they are the children of E. E is the parent of K and the L. Right? So this will be regarding your parent-child relationship. The next one, B, C, and the D, if we take up the example, C and the D, they are the sibling of B. That is, if I take up C, B and D are the sibling of C. If I take up the D, B and C, they are the sibling of D. Sibling means these are the children of the same parent. The children of the same parent, we call them as a sibling. Right? The next one, the terminal nodes. These are the nodes whose degree is 0. These are the nodes whose degree is 0. So if I means which don't have the successor. Which don't have the successor. So in this case, K don't have a successor. So it is an terminal node. terminal node we also call it as a external node or a leaf node. Terminal nodes they are also called as the external nodes or the leaf nodes. The first K is the first leaf node. Then L, leaf node. F is a leaf node. G is a leaf node. Then H is not a leaf node. The reason is it has a children called M, right? But M is a leaf node. I is a leaf node. J is a leaf node. So leaf node we also call them as the terminal nodes or external nodes, and rest of the nodes are A, B, C, E, H. These are the internal nodes. These are the internal nodes. The nodes whose degree is not zero. The nodes whose degree is not zero, we call them as the internal nodes. And the nodes whose degree is zero, we call them as the external nodes or the terminal nodes. If I go with the level, A is at the level 1, B, C, D level 2, E, F, G, H, I and the J level 3. Fine. Then next one. Ancestors of M. What are the ancestors of M? First parent H. Then parent of H D. Parent of D A. Who are all the parent now ancestors? A, D and the H. They are the ancestors of M. They are the ancestors of M. Fine. So now if I go with the next. Descendants of B. Who are all the descendants of B? E, F. Then for the E, K and the L. They are the descendants of the B. They are the descendants of the B. That is ancestors and the descendants. You have to remember. Ancestors of a node and the descendants of a node. So now in this session, we learned the terminologies which are used in the tree representation. First, we have started with the definition of the tree. That is, a tree is a non-linear, non-primitive data structure wherein it will have the sequence of elements. These elements we call them as the nodes. They are arranged in a parent-child relationship, and we learned many representations of the many terminologies which are used in the tree, like root. First, we have started with the root. So, root is the node, that is the first node of the tree. We call it as the root. Then next, we learned the other definitions as the subtree. That is a subtree. The tree is made up of a small number of subtrees over there. So, each subtree is again a tree. Each subtree is again a tree. Then we learned the what is a parent, what is a child, what is the ancestors, who are all the descendants, what is the degree of the node, what is the height of the node. So these things we learned in this session. The textbooks which are referred for preparing this video will be from the textbooks Ellis, Horowitz and Sartaj Sahni. The textbook name is Fundamentals of Data Structures in C, second edition. It is a Universities Press 2014. And the second textbook is Data Structures from the Shams Outline Series. The authors Xavier Lectures. It is a revised first edition, Tata McGraw-Hill 2014. Thank you.